Okay, in this video we're going to look at the log function. Okay, so the log function is defined as the inverse of an exponential function. So, for example, if we have f of x equal to 2 to the x, you know how to graph this. Okay, it is like this, goes up, and a key point on there is 1. Okay, so 2 to the x, and then f of 1 is 2, and so on. F of 2, okay, so 1 is 2, f of 2 is going to be 4, because 2 to the 2 is 4. F of negative 1 is 1/2, okay, and so on. So that's 2 to the x. Now, if I want the inverse of a function, what I'm going to do is I'm going to reflect it in the line y equals x. Okay, so I'm going to put on here the line y equals x. Okay, so there's the y-axis, x-axis. Okay, and I'm going to reflect it in there, because when you're doing the inverse, you're swapping the x and the y's. That's why you're just reflecting in here. So this point is now going to go over here. Okay, and this point is going to go over here. Okay, so it's going to be the opposite. So that was point 1, 2. Okay, and now it becomes a point 2, 1. And then this one here, which is negative 1, 1/2, is going to become 1/2 negative 1. So it's going to become there. And it's going to continue on in this pattern, so that this asymptote here, when I reflect it in the line y equals x, becomes this one. Okay, so if I reflect it, this point becomes this point. This point becomes this point. The origin stays the same. So, a function that looks like this. Okay, so this is the function 2 to the x. This is called the function log base 2 of x. Okay, so not the nicest notation, doesn't really look like our other notations for inverses, but this is what it is. Okay, now if I wanted 3 to the x, the inverse for that, okay, similar thing, draw 3 to the x, just goes up steeper. Okay, it looks the same thing. So that goes through 1, okay, because 3 to the 0 is 1, so there's y equals 3 to the x. And then if I reflect that in this line here, then I get this function here, so that 1 becomes there, and I get that. So that's going to be log base 3 of x. Okay, and the 3, when I say base 3, it's because it was the base of the power. Okay, so it's log base 2 because that's base 2. So log base 10 is a common log that you see on your calculator, and it would be the inverse of 10 to the x. Okay, now something you can think of for this, if they are inverses, then what we know about composition of functions, so if f of x equals 2 to the x, and f inverse of x equals log base 2 of x, okay, we know inverses cancel each other out. So f inverse circle f of x, so we compose them, we get log base 2 of 2 to the x, and that should equal x. Okay? Now, when we think of inverses, before you plug in a number here, so 2 to the 3. So 2 to the 3 is 8. If I then go log base 2 of 8, that gives me 3 back. Okay? So 2 to the 3 equals 8, which implies that log base 3 of 8 equals, log base 2 of 8 equals 3. That was the input there. Okay, we take the output and we make it the input of the inverse, and we get that original input back. Okay? Now, one way of looking at this without doing this whole thing is log base 2 of 8. If you want to evaluate that, you're just thinking of 2 to the what equals 8. So 2 to the what equals 8. That's what you're putting there. Okay? So another example would be if 3 to the 3 equals 27, which it does, then log base 3 of 27, so that was the input, so log base 3 of 27 equals 3. If you go 3 to the what equals 27, the answer is 3. So that's how you evaluate logs. Okay. Another example. Okay, so we want to make sure we've got this log law here isolated. So this would be good for the chemists. 10 to the 5 equals 1 with 1, 2, 3, 4, 5 zeros. Okay? So then log base 10, on your calculator, it just shows log. It doesn't show a base 10. So it's understood that log of something equals log base 10. Okay? So log and log base 10 are the same thing. If it's any other base, you have to put it in, except for one special one, which is the exponential number e. Okay, so log base 10, why did I put an equal sign there? Of 100,000. Okay, so log base 10 of that. Well, 10 to the what equals that? 5. Okay. So again, that could have been just log 100,000 equals 5. Okay, and you can check that on your calculator. Now another way of looking at this, so we've got this inverse. Okay, what if we did it the other way around? What if we did f circle f inverse of x? Okay, it should give me the same thing. Remember, the inverses, no matter how you compose them, gives you the same thing. Okay, so from a previous video. So in this one, we're going to do, the outside function is 2 to the x, and we're going to put f inverse in for the x, which is log base 2 of x. Okay, and this, because when you compose a function with its inverse, gets you what you inputted back, you get that. Okay, so this is an important one that we have here. Now, an example of that would be 3 to the log base 3 of 7 just equals 7. Okay, these cancel each other out. It's like square rooting an x squared. Okay, so if you did 7 squared and then square rooted, that equals 7. It's the same effect. Okay, so that's it for this video.